this is the key to 14.5 Part B, and again, you're solving rational equations. Now, in these rational equations, if you notice your denominators, they all contain they all contain variable expressions. So if you go to each one, all of them contain variable expressions. Whereas in Part A, remember when you did Part A? This rational equation only contained numbers, and then in number 2, that's when we started looking at variable expressions. See, that's a variable expression, that's a variable expression. That's a constant right here. Now in Part B though, notice that you're having more than one monomial. See, all these were one term, one term, one term, one term, one term, one term, one term. Now we're dealing with more than one term. Okay, so here's what you got to do. So the first thing you have to do is make sure that your denominators are factored. Okay, you got to factor your denominator. So if you look at x plus 3, I can't factor that. And then here, that's really 4 over 1, so that's going to be a 1 down there. And then x plus 3 again, I can't factor. All right? Now, what you want to do next is this. You want to find your restrictions. Okay, so you're going to ask yourself, what makes the denominator 0? Because remember, in finding the restrictions, you're finding the values of the domain that makes my rational expression undefined. So when is this rational expression undefined? What's undefined, and here's what you did in the lesson. You first of all said, well, I'm going to set that equal to 0, and I want to see where that's 0, right? Because you're trying to find out where's this expression equal to 0. Well, that's linear, so just subtract 3 from both sides and get x to be negative 3. So that's one of your restrictions, negative 3. Then you go to the next rational expression. That's 4 over 1. And so that doesn't have a variable in it, so I'm done. I just go to the next one. Well, that is the same as this, so I already did it. That's negative 3. So there's only one restriction, x equals negative 3. Okay. Now the next thing you have to do is find the least common denominator. Because remember, in the previous lesson, the whole point of multiplying by the least common denominator is to get these factors being 1 down here instead. All right, so you want to clear your fractions. You want to clear those fractions. So you notice when I cleared my fractions, clearing the fractions, you need those factors to be 1s. And so notice I ended up with something that looked complicated to something that was a linear equation. So that was pretty easy to deal with. Okay? So same idea here. So your least common denominator has to include every factor you see. All right, so listen to this. So the first factor I see is x plus 3, so I'm going to put it. And so that has to be in the least common denominator, because remember, if I want to get this to be a 1 right here, then I have to multiply by something that this goes into. So this right here, the least common denominator has to include x plus 3. All right, that's the 1, so don't worry about it. Here's an x plus 3, but I already took care of it, so that's already listed. So the LCD is just this. That's your LCD. All right, now watch. What's going to happen next? Okay, so now you're going to notice that when we did Part A, remember we said this has two rational expressions. I need to put that in parentheses. The reason we put that in parentheses is because both of these has to be multiplied by 12. All right, so that's where the distributive property comes in. So notice the first rational expression will be multiplied by 12, and the second will be multiplied by 12. In fact, just keep in mind, if you notice, every rational expression in your equation is being multiplied by 12 in it. So this multiplied by 12, this multiplied by 12, this multiplied by 12. So using that idea, don't you think that this has to be multiplied by what? X plus 3. This has to be multiplied by what? X plus 3. And this has to be multiplied by what? X plus 3. Okay? All right, now what I would do is, again, just like with the previous one, let's put that one in parentheses, the left side, just like this. All right, just like that, equal, and then 2x divided by x plus 3. Remember, we didn't put this in parentheses because that was just one rational expression. See, I just have one there, so I'm going to leave it alone. Now remember, what we're going to do next is we're going to multiply by the LCD. So x plus 3, put that in parentheses, x plus 3. Put it in parentheses so you don't mess up. Put that in parentheses. All right, now we're going to distribute. All right, so here's what we're going to say. the LCD times the first rational expression, just like this. Okay, minus, and then this times the LCD, just like this. Notice the reason why the parentheses was important, because if you didn't put that in parentheses, you'd forget about multiplying 3 by -4. And then equal, and then we're just going to rewrite this over. All right. Now, once you multiply both sides by the LCD, now we're going to reduce. So the whole point of reducing is to get these denominators, so you have to factor 1, and now I can reduce now. X plus 3 into x plus 3, you get factors of 1s. And then same thing here. All right. Now, let's see what we get. 1 times 3x is 3x, right? Minus, and then let's distribute here. Minus 4x minus 12, right? Equal, and then over here, 2x, all right? So notice I went from a complicated equation, a rational equation, to a linear equation. Notice this is a linear equation. And so to solve a linear equation, I'm going to combine like terms. So that's a 3x and a negative 4x is a negative x minus 12 equal 2x. Adding x to both sides, I combine like terms, I get negative 12 equals 3x, right? And so I'm going to go ahead here. So I get negative 12 equals 3x. Okay. Then divide both sides by 3. I get x to be, what's that, negative 4? All right, negative 4. Okay, so notice that negative 4 is not a restriction. So if I did this correct, if I did all this work correct, then my solution is negative 4. Okay? Now let's check it. Let's go ahead and check this. All right, the way to check this, just like we did before in the previous lesson, remember when we did this right here? So wherever we saw the variable x, you substituted your solution. All right, notice we put all those in parentheses. It's important, otherwise you may mess up when using your calculator. So let's just check this. Let's just go quickly and check this. So you go back to the original equation, which is this. Always go back to the original. Always. So we're checking x equals negative 4. Okay? So I'm going to go ahead and rewrite this over. So here's my equation. So the equation is 3x divided by x plus 3 minus 4 equal 2x divided by x plus 3. So where I saw the variable x, I'm going to substitute negative 4. That's what that's saying. So I get 3 times negative 4 divided by negative 4 plus 3 minus 4. And I want to see if that's going to equal this side. And that side's 2 times negative 4 divided by negative 4 plus 3. Now, when we did this one earlier in another worksheet, we used our calculator with this. All right. Here, I'm not going to use a calculator because it's easy to deal with. What's 3 times negative 4? Well, that's negative 12, right? What's negative 4 plus 3? Well, that's negative 1. And then minus 4. Okay? And on this side, what's 2 times negative 4? Well, that's negative 8. What's negative 4 plus 3? Well, that's negative 1. See, you don't need a calculator here. What is negative 12 divided by negative 1, though? Well, that's positive 12. 12 minus 4 is what? It's 8. And what's a negative 8 divided by negative 1? Well, that's 8. That's 8 as well, right? So those two are equal. So x equal negative 4 is correct. All right? So that was the check for number 1. Okay, now let's look at number 2. All right, so number 2, and I may need more room, so I'm going to try and not write as big on this one. So here's number 2. So when we did number 1, remember we had to find the restriction, we had to find the LCD, and even before we did all that, we checked to see if we could factor the denominators. Okay? Same thing here. So if you look at that first rational expression, can I factor this denominator? No. If I look at the second rational expression, can I factor that denominator? No. But if I look at the third rational expression, that's a quadratic trinomial. Let's see if I can factor this. So we're going to go ahead and see if we can factor this. Now, usually what happens is this. Whenever you have a trinomial like this, usually one of your factors will be one of these listed. All right, so that's usually, most of the time, not always, but most of the time it will be. So let's say 3x, x, and then let's say 2, 1. So let's see if that works. Yep, that's going to work. and the last sign's negative, and the middle sign's positive. That means that this is positive, and this is negative. All right, so let's see if I get this back. I kind of messed this up. Let's see. Oops, nope. Okay, I messed this up. So that's 3x and what? 2x, right? Okay, so 3x and 2x is 6x. Okay, so here we go. And then I need the 2 to be here, the 1 to be here. And that's going to be positive, that's going to be negative. And now it works. Okay, so 3x times 2x is 6x squared. The outer is negative 3x, the inner is 4x, and so I get a positive x. And then 2 times the negative 1 is a negative 2. And see that, remember a while ago I said usually when you factor this, one of those factors will be one of these listed. And so you see this right here is this one. Okay, now let's find the restrictions. Okay, so listen carefully. You're going to ask yourself, what makes this denominator 0? What value of x, what number, what real number will make this denominator 0? All right, whatever makes that denominator 0 is a restriction because you can't divide by 0. So what you do is just take that denominator and set it equal to 0. So you solve this equation. So you get 2x equal 1, so x is 1/2, right? So there's one of your restrictions, 1/2. So if you do all this work and I get 1/2, then I can't use 1/2. That's not a solution. Let's go to the next one. 3x plus 2, same thing. 3x plus 2 equals 0. I solve this linear equation. So I get 3x equal negative 2. Divide by 3. So I get x to be negative 2/3. So that's your other, put comma, and put negative 2/3. So x cannot equal 1/2 and x cannot equal negative 2/3. All right? Okay, now let's find the LCD. So remember your LCD has to include every factor you see. So notice this is an x plus 3. I had an x plus 3. This is a 1, so 1 is a factor of everything, so you notice I didn't put a 1 there. This is x plus 3. I already had it listed. Over here, though, 2x minus 1, I need to list it. Right? Then my next one is 3x plus 2. I've got to list it again. But notice that your LCD, whenever you put them, those are products. So now you got to come back and put this in parentheses. So 2x minus 1 times 3x plus 2. Then I go to my next factor, 3x plus 2. I already have it listed. Don't list it again. You list it again, you're not doing the least anymore. And it makes things a lot harder on yourself. Only list it once. And then it says 2x minus 1. I already have it listed. So your LCD only includes those two factors. And notice that those two factors that contain variable expressions, and you solve each one 0, that corresponds to your restrictions. All right, so so what makes this 0 is this. What makes this 0 is this. Okay? All right, now I'm going to go ahead and I'm going to need more room, so I'm going to put this on scratch paper. Okay, so work is on scratch paper. All right, so basically I'm going to go ahead and rewrite the problem over, and then once we found the LCD, we're going to multiply both sides by the LCD. All right, so I'm going to go ahead and just rewrite the problem over. Now, when you write the problem over, so remember earlier, since this has two fractions, two rational expressions, put that in parentheses. Okay? Put that in parentheses. All right, now when you get to this side, listen carefully. Don't use this. Use your factored part, and there's a reason. There's a reason for that. Use your factored part. So I'm going to write this as 9 divided by 3x plus 2 times 2x minus 1. Okay? All right, now let's multiply both sides by the LCD. So remember, your LCD is this. So you're going to say 2x minus 1 times 3x plus 2. Over here, 2x minus 1 times 3x plus 2. So again, notice the reason why I asked you not to write it like this, but to use your factors, because these factors are listed. Okay, you can see them. All right, now mistake people make is they reduce first. You cannot reduce first, because look, if you reduce first, and then all you're going to be doing is distributing this, and that's not what happens. Okay, so this expression right here is not being multiplied by just this. It's being multiplied by both of those. All right, so you have to be careful. So you have to you have to distribute first and then reduce. Distribute first, then reduce. Okay, so distribute first, then reduce. Okay, so we get the LCD times the first rational expression. Write it out. Write it out so you don't make a mistake. Just like that. Minus the LCD times the second rational expression. Equal. Now I'm running out of room, so I'm going to go ahead and do this right now. I'm going to go ahead and reduce here. So the 3x plus 2's divide out, right? The 2x minus 1's divide out. So notice you get 1's in their place. Remember the whole point of multiplying by the LCD is to get these to be 1's. So I get 9, and then 1 times 1's 1. So what's 9 over 1? Well, that's just 9. Okay, now let's reduce here. So reduce. I get 2x minus 1's divide out. And I get 5 times this. I'm going to go ahead and write it. 5 times 3x plus 2, right? And over here, the 3x plus 2's divide out. Notice I got 1's in the denominator. That's what you wanted. So the whole point of multiplying by the LCD is to get that to be a 1. So this denominator better be in your LCD. This denominator better be in the LCD. And now I'm going to have 7 times this. So minus 7 times 2x minus 1. And all that's equal to 9. So notice I went from a complicated equation to a simple linear equation. So I have this linear equation. All right, now I'm going to distribute. And so I get 15x plus 10 minus 14x plus 7. A negative 7 times a negative 1 is a positive 7 equal 9. Combine like terms, 15x and negative 14x is x. 10 plus 7 is 17, equal 9. Subtract 17 from both sides. I get x to be, what's that, 8? Negative 8, right? It's negative 8. All right, now, remember, once you get to that point, assuming I did all this work correct, and that's a lot of work, so you could have easily have messed up. Assuming you did all this work correct, you need to look at your restriction. Is negative 8 any of these restrictions? No. So since those are not restrictions, since negative 8 is not one of my restrictions, then my solution is going to be negative 8. Now let's check it. So there's going to be the check for number 2. Okay, number 2 check. So we're saying x equal negative 8, right? Okay, negative 8. So I go back to the original. You must always go back to the original. So I'm going to write the original over. 5 divided by 2x minus 1 minus 7 divided by 3x plus 2 equal 9 divided by, and then now I'm going to use this because I could have messed up the factoring. So I always go back and use this. Minus 6x squared plus x minus 2. All right, always go back to the original. All right, so I get 5 divided by 2 times negative 8 minus 1 minus 7 divided by 3 times negative 8 plus 2. And I want to see if that's going to equal this side, which is 9 divided by 6 times negative 8 squared plus a negative 8 minus 2, right? Okay, now I'm not going to use a calculator with this because it's easy to do this without the calculator. So my numerator is 5 at this point. My numerator is 5. What's 2 times a negative 8? That's negative 16. And a negative 16 and negative 1 is a negative 17. Over here, numerator is 7. 3 times negative 8 is a negative 24. Negative 24 plus 2 is a negative 22. And I want to see if that's going to equal 9. All right, a negative 8. Now you may want to use a calculator with that one. A negative 8 times itself is a positive 64, right? So 64 times 6 plus 64 times 6 plus a negative 8 minus 2 equal, so that's 374, right? So 9 divided by 374. All right, now what I would do here is use the calculator with this and let's approximate. So 5 divided by negative 17, just like this. And then minus, now some of you would realize that's a plus, right? So subtract the negative becomes an addition. So that's an addition problem. All right, but if you didn't see this, you'd say minus 7 divided by negative 22. Press equal, and that's about 0.02406, and so on. Let's see what this is. Oh, and by the way, so you didn't have to approximate this like this. You all know how to convert this back to a fraction, right? You just press second P or B, remember that? And then press equal, and then notice you get 9 over 374, which is what this is. So you really didn't have to convert that to convert it to a decimal, approximate it to a decimal. You just get this. All right, so what I have, x equal negative 8 works, so that's a solution. All right, and then number 3, let's look at number 3. So number 3, you have this. So same idea, you have to factor the denominators. Now you see that first denominator, how are you going to factor that? You have to factor it if you can, so you can factor out a 5, right? So that's 5 times x plus 1. The second denominator that you see here, I cannot factor that, so that stays x plus 2. Now here, this trinomial I can factor as x plus 2 times x plus 1. Okay? And now let's look at the restrictions. Now you got to look at all your factors. See, this denominator has two factors, a 5 and x plus 1. Well, that's never 0. That's always what? 5. All right? And first of all, it didn't even contain a variable expression, so I'm not even going to worry about that. This contains a variable expression, so now you got to think about your restrictions. When is x plus 1 equal to 0? X plus 1 is equal to 0 and x equal to negative 1. So negative 1 is one of your restrictions. Let's go to the next one, x plus 2. That contains a variable, so I need to look at my restrictions. When is x plus 2 equal to 0? Well, x plus 2 is equal to 0. X plus 2 is equal to 0 when x equal negative 2. So there's another restriction. Let's go to your next one. X plus 2, I already dealt with it. That's my restriction. X plus 1, I already dealt with it. That's a restriction. So you only have two restrictions, negative 1 and negative 2. All right? Now let's talk about the LCD. Your LCD has to include every factor you see. I see a 5, I have to use it. I see an x plus 1, I have to use it. Because remember, the whole point of multiplying, of defining the LCD is to multiply both sides by the LCD. And the whole point of multiplying by the LCD is to get these factors down here to be 1s. And so if I need that to be a 1, then that has to be in the LCD. I see an x plus 2. Do I have it listed? Nope, so I must list it. I'll go to the next one. I see an x plus 2. Do I have it listed? Yes. I see an x plus 1. Do I have it listed? Yes. So that's your LCD. So your LCD is 5 times x plus 1 times x plus 2. Don't list it again. If you list it again, you're making this so much complicated and you're not going to know what to do. So you're trying to find the least. If you put x plus 2 again, that's no longer the least. That's a common denominator, but it's not the least. All right, so just use the least. That's why we call it the least common denominator. That's why it's used in our process. Multiply both sides by the least common denominator. All right, and just like we did with the previous problem, when we did number 1 and number 2, we're going to multiply both sides by the least common denominator. I know sometimes we put those in parentheses. So when I do this one, the left side only has one rational expression, and make sure when you rewrite it, you put the factored part. So this becomes x divided by 5 times x plus 1. The right side's the one that has two rational expressions. Put that in parentheses. I'm going to leave some space here. I'll put that in parentheses. 1 divided by x plus 2 plus 1 divided by, and put the factored part. You're going to, just like we talked about in the previous problem, there's a reason you want to put the factored part. Because your LCD is in factored part, is in factored form, so you need this to be factored as well. So now we're going to take the LCD, we'll multiply both sides by it. And this should be an equal sign right here. So times the LCD. 5 times x plus 1 times x plus 2. And put the equal sign here. And then 5 times x plus 1 times x plus 2. Okay? Just like that. You multiply both sides by the LCD. Now, on this side, I'm going to go ahead and rewrite this over. I'm just going to go ahead and rewrite this over. So you have 5 times x plus 1 times x plus 2 times x divided by 5 times x plus 1. And then on this side, I'm going to distribute now. Get rid of the parentheses. I'm going to distribute. So I get the LCD times the first rational expression. Just like this. Okay? Plus the LCD times the second rational expression. And you remember, I said write the factored part, right? The reason you write the factored part and not this is because notice that these factors are listed in your LCD. Now we're going to reduce. So the 5's divide out, the x plus 1's divide out, and you have x times x squared plus 2. I'm sorry, x plus 2, excuse me. Equal, the x plus 2's divide out, and you get 5 times x plus 1 times 1 times 1 is 5 times x plus 1, right? Plus the x plus 2's divide out, the x plus 1's divide out, and you get 5 times 1 times 1 times 1 is 5. Okay, so that's where I'm at. All right, now I'm going to get rid of the parentheses. I'm going to distribute. So I get x times x is x squared. X times 2 is 2x. Equal 5 times x is 5x. 5 times 1 is 5. And then plus 5. Now I want you to notice in number 1 and 2, when we look at 1 and 2, remember I went from a rational equation to a linear, right? Okay? I went to the linear. And I ended up with one solution. And I had to make sure it wasn't a restriction. When I did number 2, I went from a rational equation to a linear equation. Same thing, right? Same thing, linear equation. But here in number 3, I went from a rational equation to a quadratic equation. This is quadratic. And so remember, when solving a quadratic equation, you got to put it in standard form, meaning you got to bring everything to one side. So before I do that, let's combine like terms on this side. So I get x squared plus 2x equal 5x plus 10. Now let's bring all the terms to one side. So we got to put this in standard form. Remember, standard form. So I'm going to subtract 5x from both sides first. So I get x squared. 2x and a negative 5x is a negative 3x equal 10. And I'll subtract 10 from both sides, just like that. I get x squared minus 3x minus 10 equal 0. Okay? Negative 10 and a positive 10, 0. Now, remember, at this point, the only thing that you know how to do with these quadratic equations is solve by factoring. So we're going to factor. Solve by factoring. Okay? So we're going to factor this. So I get x, 5, 2, and the 5's going to be negative, the 2's going to be positive. And so when you check it, you get this back. Now remember the zero factor property? So I'm going to say each factor equal to 0. So x minus 5 equals 0. X plus 2 equals 0. And notice what happens. You went from a rational equation to a quadratic equation to 2 linear equations. And so to solve this linear equation, I'm going to add 5 to both sides. And so get x to be 5. To solve this linear equation, we'll subtract 2 from both sides and get x to be negative 2. All right? So those right here are the solutions to the quadratic equation, but they may not be solutions to the rational. You have to look at your restrictions. Are any of these restrictions? Yes, negative 2. Negative 2 is a restriction, right? That's a restriction. So I can't use it. The reason I can't use it, because remember, if I go here, what's negative 2 plus 2? That's 0. Can you divide by 0? No. All right, so that's a restriction. Is 5 a restriction? No. So that means if I did all this work correct, what that means is that 5 is the only solution. That's what that means. So let's check it. Let's just check 5. All right, let's check 5. So this is number 3. We're going to check x equal 5. So make sure you understand that negative 2 we can't use because that's a restriction. Negative 2 makes that denominator 0 right here. It even makes this 0 as well, right? Because what's negative 2 plus 2 is 0. All right, so let's check 5. Now remember, you must go back to the original. The original that's not factored. So you have to go back to the original. So here is the original. You have x divided by 5x plus 5 equal 1 divided by x plus 2 plus 1 divided by x squared plus 3x plus 2. Okay? And so wherever we see an x, I'm going to substitute 5. So I get 5 divided by 5 times 5 plus 5. And we see what that's going to equal 1 divided by 5 plus 2 plus 1 divided by 5 squared plus 3 times 5 plus 2, right? Okay. Now let's do it by hand first, and then if we need to, we'll go to the calculator. 5 times 5 is 25, right? What's 25 plus 5? 30. So I get 5 divided by 30. And I'll see that's going to equal 1 divided by, what's 5 plus 2? 7 plus 1. Okay, now some of you may need to use a calculator here, but you all know that what's 5 times 5? What's 5 times 5? 25, right? So you're going to say 25 plus, what's 5 times 3? 15 plus 2 equal 42. Now what I would do is I would go ahead and put those two in the calculator. So 1/7, 1 divided by 7 plus 1 divided by 42 equal, and then convert that back to a fraction. So we're going to say second PRB and then press equal, and you get 1/6. So that's 1/6, right? Is that what this is? Yes, because 5/30 is reduced as 1/6, so that's true. So x equal 5 is the solution. All right, so number 3 was complicated. The only reason why number 3 was more complicated than the other two was because you went from a rational equation, and the fact that you had to factor the denominators. But still, you went from a rational equation to what kind of equation at this point? Quadratic. And so to solve this quadratic equation, remember the only thing you know at this point is to solve by factoring. And so you bring everything to one side, so that's standard form. You factor, use the zero factor property. So you get these two proposed solutions. This right here is a restriction, so x equal 5 is the only solution. That's the only solution. So we can't use this. This is not going to be part of our solution. So that's why you don't see it here, because -2 is a restriction. Okay? All right, so that was the key. So it was pretty complicated. Solving rational equations is not an easy task, but it is doable if you just keep practice with it. You can master this. So 14.5 part B, that was the key.